Okay, in this video we're going to talk about confirming whether data is proportional or whether data shows proportionality in a relationship or not. So here we have some data for cake cases that have been dropped. So we've got some experiment here where, for example, we've dropped some paper cake cases just like this through a certain distance. Okay, so we've dropped them like that. We've measured, we've got the distance, we've timed how long they take to fall, and then we've obviously worked out their speed or their velocity from distance over time, okay? And then we've just squared that, okay? And what we're trying to look at here is, as we increase the number of cake cases, so we've dropped one cake case, worked out its velocity, then dropped two and worked out the velocity for that, and then dropped three and worked out the velocity for the three being dropped, and then we've squared all those values. So the square of the velocity for one paper cake case is 1.24 meters squared per second squared. For two, it's 2.59. For three, it's 3.29. And the question is the number of cake cases proportional to the speed squared? Okay. Now, if speed squared is proportional to the number of cake cases, then we know that we can write this mathematically, okay? So hopefully you know this from maths, that you can make this into an equation by doing v squared equals a constant multiplied by the number of cases. So if v squared is proportional to the number of cases, v squared equals k times the number of cases. So what we can do now is, if this is proportional, if the relationship is proportional, if we rearrange this equation to get v squared over number of cases, that should always equal a constant k. Alright, so we can now decide whether these things are proportional. Now, there is another way of doing this. You could plot a graph of v squared against number of cases, and it should be a straight line through the origin. But in this question, for example, they've maybe asked you whether these things are proportional without plotting a graph. So to prove that, we're just going to do this. V squared for 1 is 1.24. The number of cases is 1. So 1.24 divided by 1 gives us 1.24. Okay, that's our constant here. Now, if we then do that for 2 cake cases, 2.59 divided by 2. Now that's going to give us 1.30. Okay. And then if you look at the third cake case, 3.29 divided by 3, well, that's going to give us 1.10 to 2 decimal places. Okay. So the point here is, this is k. This is supposed to be k. Each of these is supposed to be k. Now, k is supposed to be a constant. These are not constant. So because this is not constant, because this is not exactly a constant each time, then we can say that v squared is actually, we can say that v squared is not directly proportional to the number of cases. It's close, but it's not quite proportional. In order for it to be proportional, each of these values would have to be the same when you calculate them. Okay, so let's do perhaps another example here. Let's say now that we've got some quantity y, and let's say that y is equal to, we're saying that y is equal to kx. Are y and x proportional? Well, let's say we take some data, and x is 2.00, 4.00, 6.00, and y, let's say, comes out as 6.00. Let's say that this time that this comes out as 12.00, and this time it comes out as 18.00. So are y and x proportional? Well, to find out, we're going to do y over x, and that should equal a constant. Okay, because remember, if y is proportional to x, y equals kx, where k is a constant. So let's do that. 6 over 2 gives us 3. 12 over 4 gives us 3. And 18 over 6 gives us 3. So in this case we can say yes, y is equal to kx. Y is directly proportional to x. Okay. So there's some examples for you, and perhaps I'll do another couple of examples on the next video.